Good morning, everyone, and welcome to the class today. This is, I think, lecture number 11 on work, power, and energy. Up till now, what we have covered in the previous lectures is how to find out work done by a force, constant force, variable force, one-dimensional force, two-dimensional force. We have done all types of questions. We have also seen that we can find out work done by force by the area under the force displacement or force position graph. An interesting thing that we saw was two types of forces, conservative and non-conservative, and that is where we are concentrating on right now. As you remember, in the last class we had discussed something known as energy. Kinetic energy is already done, work energy theorem is already done, and we were discussing the concept of potential energy. And what we discussed was simply potential energy is the energy. Okay, okay, but I got it. So, potential energy is what we are talking about. And when we talk about potential energy, well done. Okay, I can see you. I can see your messages better. Potential energy is an energy which is acquired by a body by virtue of its position. Potential. It is stored. You can say someone told me that it's an energy that is stored. Yes, it is energy that is stored. Now, where and how this energy is stored, that is what we were discussing in the last class. So we had seen that, and this energy is very easy to understand because physics is easy to understand. You can see everything. Kinetic energy, something is moving fast. It has energy. You can see that energy. That energy can be used to do work. Similarly, here, potential energy. You can easily see potential energy in work. And the simplest example is right now, wherever you are sitting inside what we call as gravitational field of Earth. Earth is a huge mass. It attracts other bodies. How does it attract? It creates gravitational field around it. If another body comes in that gravitational field, it will experience gravitational force. We know that. Now, good morning, Abhiram. Now, because of this gravitational force, the body will get attracted. This pen falling down because of gravitational force. This pen falling down because of gravitational force. This gravitational force is created by the gravitational field of Earth. So we have the concept over here. Gravitational force is created by gravitational field. This gravitational field creates gravitational force. Now you can think of it in a different way. Wherever you see, there is energy, there is potential. At this point, there is some potential. At this point, there is some potential. At this point, there is some potential. Why is this potential present? This potential is present because of Earth's gravitational field. Earth is creating gravitational field around itself that creates potential in the entire space. Now, if I place a body at that point, that potential becomes potential energy or gravitational potential energy. And that is what we are concerned about, potential energy or gravitational potential energy. Now, this gravitational potential, because we'll be studying one more type of potential energy, which is known as electrostatic potential energy, that would be coming in the next year. Both are pretty simple, small differences, which you will understand once that chapter comes. Right now, what we are going to understand is gravitational potential energy, or for that matter, any type of potential energy. So, what is this potential energy? Let us start making some notes. Potential energy. Potential energy. This is the energy acquired by a body. You can simply write it, energy acquired, energy acquired, energy acquired by a body by virtue of its position in space, by virtue of its position in space. It can be in space, it can be anywhere by virtue of its position. Now, instead of using the word position, which is a very simple term, you can use another term here. I will write it in red. We can call it as configuration, position or configuration. How it is arranged, where it is placed, and how it is arranged. Energy acquired by a body by virtue of its position or its configuration. That is potential energy. Now, it can be of two types, can be of many types. Basically, what we are going to see are three types of potential energies. In fact, four types. I can call it four types, basically same thing. The first type is gravitational potential energy, which we would be studying in this particular chapter, next chapter as well. Electrostatic potential energy, 12th standard. Spring potential energy, we will study this in this particular chapter. And elastic potential energy, you can call this elastic potential energy and spring potential energy, both are same. They are coming both in springs or something which is elastic. I've just written that down separately because you might have heard this term elastic potential energy in your chapter on elasticity. I think the chapter has already been covered. So you must be aware of this term elastic potential energy, and that is why I wrote it separately. I could have written it with spring potential energy because they are same, coming because of the elastic nature of the spring. I think you would have read it as elastic potential energy, and that is why I have written it as separately. Do you know about elastic potential energy? Have you heard about this term in the chapter of elasticity? I think that chapter is already covered. Yes or no, Abhiram? The chapter has been covered, elasticity. Yes or no? Anyone in the class? Okay, so it has been covered. So you must be knowing about this energy. Whenever you have a rope which is elastic or rubber band which is elastic, you change its length. It will try to come back to its original position, original configuration, original length, and we have energy stored in that rubber band or any elastic body. That is elastic potential energy, which is actually same as spring potential energy. So I'll also mark it green. So spring potential energy we are going to cover here in this chapter, and the other one is known as gravitational potential energy. So these are the three energies that we will be dealing with in this year in this class. Electrostatic energy would be done in 11th standard, but everything is pretty simple. Same. If you understand one energy, you should be able to understand the other energies, and that is why I'm spending so much time. If you can understand gravitational potential energy, you will be able to understand electrostatic potential energy and your journey in 12th standard, because in 12th standard almost three-fourths, or I should say two-thirds of your course is electrostatics and electricity. So if you understand this, probably you have covered almost one-third or one-fourth of the course of the 12th standard. That is why I'm spending so much time here, and we have time. Now let us try to understand how I'm going to define it. Now, I don't know what I mean. Sometimes students ask me doubt, and they send me some picture from some notes, then ask me, sir, what is this? What is wrong with this? See, most of the books that you find around yourself, they might not be giving you a very correct definition of things. They might be telling you things in the simplest possible way, and sometimes when that thing is said in the simplest possible way, the main essence of that thing is lost. You lost the main essence. What it means, you lose it, and you think that you've understood it. For example, distance. For example, displacement is not the shortest distance. Displacement has got nothing to do with shortest distance. Nothing to do with shortest distance. But to make you understand, if someone tells you in ninth standard that displacement is the shortest distance, okay, that will make you understand. But the concept of displacement has totally been lost. You have lost what is displacement, but probably you have understood it. Sometimes it happens, but what I'm going to do is not give you a simple definition. I'll try to make you understand, but I also try to make you understand how it is defined. That is important. Now, this gravitational potential energy actually is defined in a different way. We call it difference or change in gravitational potential energy. So basically, this gravitational potential energy is not defined. What is defined is the change in the energy, how much it changes. Now you will say, sir, what do you mean by that? Think of a number line. Think of a number line. In number line, there is some zero somewhere. Since you know that there is a zero, then if I tell you a number is 15, then you understand that, okay, how big that number is, because you know what is zero. To define anything in physics or in life, you need a reference. Here, your reference is your zero. On a number line, your reference is your zero. Zero is where things start. We assume that it starts. The universe started at Big Bang. So that is the time when everything started, Big Bang. That is our reference point. Whenever we are talking about how old is Earth, how old is the universe, we are stuck talking about the Big Bang. That is the first incident that probably happened in this universe. Everyone must have a reference point. Now, this gravitational potential energy also has a reference point, but sometimes it may not be easy for us to find out that reference point. Where is that zero of gravitational potential energy? And therefore, the absolute value of gravitational potential energy is not defined. For example, I am in a gravitational field. Very good. Yes, we are in a gravitational field. Now, if someone tells you this pen is placed here, this pen is placed here. This is a gravitational field. This pen is placed here. This is the ground. Let us say the height is h. So I'm going to draw this diagram here and watch it very carefully. I'm taking a lot of time on this chapter. The reason is very simple, because this will come here, this will come in gravitation, this will come in electrostatics. If you understand it here, you are doing a lot of hard work. And I always want my students to do hard work with me so that they have an easier life when they are doing something else. Okay, let us say this is ground. Ground. This is ground, and I have some point here. Now, if I have some point here, and obviously I'm talking about ground, that means I'm talking about Earth. If I'm talking about Earth, I'm talking about the gravitational field of Earth right now. So Earth has its own gravitational field, and this point has some potential. It only has a potential. It is not energy still. What do I do here? I place a body of mass m. Are you following me, everyone? Abhinav, are you following me in the class? Are you following me? What's happening in the class? I don't see you, so I just have to imagine that you are following me. Okay, so now I have put a mass here. So this pen has been put here. Now this pen, when the pen was not there, it was only potential, gravitational potential. When this pen comes, it becomes gravitational potential energy. Now let me say that this height is h. It is placed at a height h above ground. Now I ask you this very simple question, a very basic one. Do you know how much gravitational potential energy this body has now? How much gravitational potential energy this body has now? I guess you have heard the term potential energy. I ask you now, How much energy do you think this body has at this point? Anyone has any idea? If you have any idea, you can write it. Else, I will continue with my. Wait for a minute. How much gravitational potential energy this body has? I've placed it at a height h above ground. How much gravitational potential energy this body has? I'll wait for a minute so that I think you will have to type. The students on the class have to type. So I'll give you a minute and I'll let you think about how much gravitational potential energy this body has. 1 minute. I hope you have thought about this question. How much gravitational potential energy this body has? Now, if you have read about gravitational potential energy, you might have come up with this answer that, sir, the gravitational potential energy of this point is mgh. You might have thought about this answer. If not, well, this is probably the answer that everyone who knows a bit about gravitational energy or gravitational potential energy would give me. Sir, the gravitational potential energy is mgh. And then I look at him, I'll say, beta, well, you probably have missed a very simple point here. What is the simple point? So the answer is both correct and both misleading at the same time. I will not call it wrong. Wrong would be a very harsh word here. So your answer is misleading me. What do you mean by this? What do you mean by this mgh? As far as I know, you will call it plus mgh. So okay, I'll put plus. Oh, wrong color. So I'll put plus. No, no, still it is wrong. No, let me not call it wrong. Let me call it misleading. It is still misleading because I would tell the kid, I will tell the student, "Ki, beta, the absolute value is not defined." So if someone tells us that the energy at this point is mgh, that is conceptually wrong. Why it is conceptually wrong? Because absolute value of gravitational potential energy or electrostatic potential energy or spring potential energy or elastic potential energy, the absolute value is not defined, and that is the first important point that we must remember. Point number one, everyone write it together. Absolute value of any potential energy, so I will just write it potential energy PE. Absolute value of potential energy is not defined. That is the first thing that we as kids, as students of physics should remember. Absolute value of potential energy is not defined. Now, if absolute value of potential energy is not defined, then what is defined? So we must also answer this. So that is the next point that we will write. Only the change, and the most important word here is change. Only the change, or you can also call it difference. Only the change or difference in potential energies is defined. Now you will say, sir, what is the difference between these two terms? You have called one thing as change and you have to call one thing as difference. So I will also elaborate on that because this is a term which I'll be using a lot many times. So it's prudent that I define it. What do you mean by change and what do you mean by difference? Let me take 2 points here, point A and point B. I'm moving from point A to point B. Here, I'm moving from point A to point B. So my point A becomes my initial point. I hope everyone is following. Point A becomes my initial point, whereas point B becomes my final point. So far, so good. If I would have been going from B to A, B would have become my initial point and A would have become my final point. So far, so good. Nothing has changed. Now, when I say change, change is always final minus initial. That is how I say it. That is how it should be said. Change is always final minus initial. Difference in energy is always initial minus final. I repeat. Change, something has changed. How much did that change? Final minus initial. Final minus initial. That is the number or amount it has changed. What is the difference between these two quantities? Initial minus final. That is how it should be defined, and that is how it is. Now, this potential energy is basically, if I just write kinetic energy, you write it as Ke or K. Potential energy is also written not as PE, but potential energy is written as U. U is used for energy. Potential energy is denoted by the letter U. Don't ask me why it's like that. Potential energy is defined by the term U. Now, when I talk about change, and I'll just write it, very simple things make a lot of difference in your life because maybe by that simple thing, the answer will change dramatically. Now, when I say, remember, I'm moving from A to B, A is my initial point, B is my final point. When I say UB minus UA, that is the change in potential energy. It can be any potential energy. Let me just take it GPE. What do you mean by GPE? G standing for gravitation, P standing for potential energy. So UB minus UA becomes change in gravitational potential energy. I can also write it as delta U, and that is the term that I'm going to use. Delta meaning change, U means energy, change in energy. From where to where I have gone? I have gone from A to B, so this is how I will write it. Delta U A to B is simply UB minus UA. Am I clear with this? Change in gravitational potential energy. Change means delta. U means energy. Delta U, change in U. A, initial point. B, final point. It is always equal to UB minus UA. Is everyone agreeing on this? Can I have some raised hand that we have? Oh, you can raise your hands. Just let me know whether you have understood this. Yes, you have understood this. I'll give you a minute again. If UB minus UA is the change in gravitational potential energy, which is delta U, A to B, what will be the difference in gravitational potential energies? So I've moved from point A to point B. Point A is my initial point. Point B is my final point. Change is UB minus UA. What will be the difference in the gravitational potential energies? GPE is gravitational potential energy. PE standing for potential energy. G cannot stand for anything else. G has to stand for gravitational potential energy. Am I clear? So, what will be the change? When I say change in gravitational potential energy or change in DP, what would be your answer? So, if I write UA minus UB, now remember, UA means energy at point A, UB means energy at point B. Do we understand this? U means energy, A means UA, energy at point A, UB, energy at point B, UB minus UA is the change in gravitational potential energy, and UA minus UB would be difference in gravitational potential energy. Am I clear with this? That is how change or difference in gravitational potential energy would be defined by me. Give you a minute to think about it. If you have any doubts, please come up. I hope everyone is clear with the two terms, change in gravitational potential energy and difference in gravitational potential energies. I'll still give you a minute. If there's anything that is troubling you, now is the time that you're going to ask me. Because if this thing is clear, then the entire concept of gravitational potential energy should be clear. 2 points we have done till now. Absolute value of potential energy, whether it is gravitational potential energy, spring energy, electrostatic energy, elastic energy. Absolute values is not defined. The only thing that is defined is the change or the difference in the values. I hope we are clear. We have written 2 points. I would add a third point. Now, how will I add the third point? I'll go back. We'll go back and go back to this question. When I ask this question, what is the value of gravitational potential energy at this point? The answer that most of the students would give me, if they have any knowledge about gravitational potential energy, would be, sir, the gravitational potential energy of this point here should be plus mgh. And then I'll tell them that, beta, okay, your answer is correct, but it is misleading. And why will I call it misleading? Because the absolute value is not defined. So how can you tell me the absolute value? But still your answer is correct. When you have said that the value of gravitational potential energy is plus mgh, what you have done in your head is you have assumed a point where you have taken the energy as zero. You can only define a value when you know where is the zero. If you know zero here, you can tell me where is 15. If you don't know zero, where is your zero? You can't tell me where is 15 because you don't know zero. There's a very famous song of Manoj Kumar in the movie Uppkar, I think, which says zero सिखाया भारत ने और zero के बिना कुछ नहीं होता. Zero के बिना सही में कुछ नहीं होता because you don't know from where to count. If there is no zero, there is no reference. Things don't make sense. If you don't know zero, you don't know what is 15 or what is 20 or what is 25. Zero. Zero is the essence. So here also, when you have told me that the value of gravitational potential energy is plus mgh, you have assumed a zero in your head. Where is that zero that you have assumed? Well, that zero is assumed here on ground. So in your head, what you have done, if you have assumed that gravitational potential energy of this point, GPE of this point is zero. GPE of this point is zero. Now, once you have assumed that the gravitational potential energy of ground is zero, then your answer is correct. Then the value of gravitational potential energy of this point at a height h, where a body of mass m is placed, has to be plus mgh. So that is the point you need to understand. First point, the absolute value is not defined. Only the change or the difference is defined. If you want to write the absolute value, if you say that plus mgh is the absolute value, it is the absolute value if zero is taken here. Now the next question that you might ask, sir, is the zero there? No, the zero is not here. You can assume zero anywhere, but for this particular case, zero is not here. Gravitational potential energy created by Earth will be zero, or gravitational potential will be zero at infinity. Earth creates gravitational field. If you go very far from Earth, then only your gravitational potential energy becomes zero. Actually. But we are not going to go to that point. Not in this class, maybe in the next chapter. Maybe no. Definitely in the next chapter, we'll be going there. Gravitation. But right now, we are not going to go to infinity. Or the zero is infinity. Let us go to infinity first. Find our zero, then we will call the energy of this point. Now that will become very confusing because then the equation will not be so simple. So instead of going to infinity to find zero, now this looks very fascinating, no? You find zero when there is infinity. This is life, this is math, this is physics. So instead of going to infinity to find zero, what you have done, okay, let us be on ground and let us call the value of energy at ground as zero. We have done that. And that will be the case in almost all of the questions that we are going to do in this chapter. Gravitational potential energy of ground would be taken as zero. It is not zero, but we'll assume that it is zero. So, third point would be there is no absolute value. To give values of potential energy at different points, if I want to give the values at different points, some point should be taken as zero. It may be zero, it may not be zero, but some point must be taken as zero. If you want to give the values of gravitational potential energy or spring potential energy or electrostatic potential energy, you must assume there is a zero somewhere. It may not be the Real zero? It may be your made zero. What do you mean by your made zero? Simple. Let us go back to the number line. Where is my number line? Number line is here. Number line is here. The actual zero is here. The actual zero is here. If you know the actual zero, you know how much is 15. But I assume that my new zero comes here. This is 0 dash. If I assume my zero is here, 0 dash, nothing changes. But 15 does not become that big a number. 15 becomes a smaller number. That's the only change. But again, if 15 becomes a smaller number, the other numbers will change accordingly. I hope you understand what I'm saying. I can change zero. You must have done it in maths. Shifting of origin, they call it. You can shift the origin. You could have done, you should have done this in straight line, where you change your axes. You change your origin, and then you find the new equation of a straight line. Shifting of origin, shifting of axis. Same thing. For example, this is the new zero is at point which was originally 5. So the new zero has come to 5. So now 15 does not become 15. 15 does not remain 15. 15 becomes 10 because it is only 10 units away from the new zero. That doesn't change anything in life. With this new zero, you can live your life as nothing has happened. Am I clear with this? What this is exactly what we have done in this case. In which case? In the case of gravitational potential energy. This is exactly what we have done. We have shifted origin. This gravitational potential energy, if I talk about in real terms, this gravitational potential energy is only zero at infinity. At a very, very large distance away from Earth. That is the point where it is zero. But if I go to that point, then the energy of this small point will be very, 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 very different. And it will become a very large quantity in negative. And it will create a lot of tension. So we are not going to create that tension now. And that is why instead of assuming that zero at infinity, let us not go to infinity right now. Let us stay on Earth. Earth is better. Gravitational potential energy ka zero value is normally taken at the ground level. And that is what we'll always do. We'll not change it. Am I clear? Can I have some raise hand that we have understood the concept here? Raise hands will give me more confidence. What about the students in the class? Do we have some concurrence here that we have understood this concept? Have you understood this concept of assuming the value of gravitational potential energy? In the class, anyone? Okay, they have sent. I did not see their thumbs up data. Okay, fine. Okay, so 1, 2, 3 points are clear. Let me just now summarize where we are going to take zero so that there is no confusion whatsoever. For gravitational potential energy, the value on ground would be taken as zero. That is actually not zero, but we will take it as zero. Now, one more thing that you must remember here, if you now take your ground as zero, then things become very pretty damn simple, because now if this is ground, and we are not going to go underground, but let us say if this is ground, in some cases you will have a block hanging. So that is the case I'm going to discuss. If this is ground, I have taken 2 points, point A, point B. Point A is at a height h from ground. Point B is at a depth h from ground. The gravitational potential energy of ground is definitely taken as zero, which we are always going to assume no matter what happens. Now, my simple question is this: based on whatever we know and whatever we discuss, can you tell me what would be the gravitational potential energy of point A and what would be the gravitational potential energy of the point B? I will give you a minute to think and give me the answer. 1 minute. I will keep my mouth shut. Okay, do I have any answers for the 2 points? On ground, I've assumed that the gravitational potential energy is zero. Can anyone tell me what will be the gravitational potential energy at point A? What would be the gravitational potential energy at point B? Abhiram, anyone in the class? It's a simple question. Think about the number line. One thing is right of number line, one thing is right of zero, one thing is left of zero, just like a number line. Anyone? I'm still waiting. No one? Okay. I will give you the answer then. The gravitational potential energy of point A would be plus mgh. It is above number line, so it is plus mgh. Then for the point which is below zero, below ground, it would be minus mgh. Am I clear with this? For ground, if it is taken as zero, at a height h, it would be plus mgh. Below ground at a height h, I should not call it height, I should call it depth. Below ground at a depth h, it would be minus mgh. Can I have some raised hands that we understand this? Thumbs up, raise hands, anything would help. Okay, what about students in the class? This is a very important concept, and on based on this, everything is going to go ahead. Chalo, I think you have understood this. I'll just move ahead. One more point that I want to discuss. Two types of potential energy are going to come in this chapter. Gravitational potential energy is one thing. The next one, which is going to be another important aspect, so let me call it as a different point. Point number 5. For spring potential energy, S standing for spring, spring potential energy. No extension when the spring is not extended, no extension wali position, which we call it as natural length, actual length of the spring, spring potential energy is taken as 0. Remember this point. Very, 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 very important. And also remember that for spring, this is the actual 0. So we are taking energy at 0, which is the actual 0. For gravitational potential energy, at ground it is not 0, but we are taking at 0. But for spring, the actual 0 also lies there. So that is the difference. It does not make any difference to our lives though. That is actually the case. Now I'm going to draw a spring. I hope you have drawn the gravitational potential energy via diagram. I'll give you a minute again to draw it. Then we will move on to spring potential energy. I'll give you a minute. If there's anything that you want to ask, you can go ahead. So now let us think about spring. So I am going to draw a spring. Spring would be normally attached to something. Now this is the natural length of the spring. This is the natural length of the spring. Sometimes we call it L or L naught, which is the natural length of the spring. At this point, the gravitational potential energy, no, I should not call it gravitational, spring potential energy is 0. This is my 0. So I'll write it here. SPE, spring potential energy, is 0 at this point. Now, we'll take two cases. If the spring is extended and the spring comes to this point, point A, it is extended by X. That is your blue point. Or it is compressed by X. So this is on the left hand side. This is point B on the left hand side. What is the gravitational, no, spring potential energy at point A and at point B? Now you will not know this, so I'll give you the results. But to remember how it is there, point A is when the spring is extended. Point B is where the spring is getting compressed. I'll give you, oops, wrong color. I'll give you the answer for this and we will not derive this because it is not going to help you at all. I'm not going to derive it. I'll give you the answer for A and then I'll expect that you will give me the answer for B. The answer for A, where the spring is extended, is half kx square with a positive sign. Positive sign is important, very important. Now you must know the value of what is half. What is half is half. Half is your number. K. Anyone can tell me what is K? What is K? We have done springs. K is your spring constant. Do you remember spring constant? K is your spring constant. And this X in this case is your extension. Extension in the spring. Spring is now getting extended. So the spring potential energy at point A is plus half kx squared. K is the spring constant and x is the extension in the spring. I'll give you a minute to win it. Can you now tell me, looking at what the answer was there, can you now tell me what will be the spring potential energy at point B? I'll give you a minute to think about it. Oh, okay. I think you have your answers, Abhidam. What do you think is the spring potential energy at point B, where instead of extending it, I have compressed it? What would be the answer at point B? At point A, the energy is plus half kx square. What would be the energy at point B, which is compressed? No answers? Well, if you're not giving any answers, I will have to give it to you. The answer would be definitely minus half kx square. Yes or no? The answer would be definitely minus kx square. Yes or no? Can I have some reasons? If it is extended, it is plus half kx square. If it is compressed, it is minus kx square. That should be the answer. But, and it's a very important but, it is not minus kx square. It is always positive. So this is the thing that you must remember about the spring potential energy. Spring potential energy, whether it is extension or compression, oops, it is always positive. It does not change signs. Remember this. Remember this. It never changes sign. It is always positive. Spring potential energy is always positive. It is never, 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 never Never, 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 never negative. And that is why I have written it as negative, so that is the first thought that will come to your mind, but that is not the real thought. It is always positive. Whether it is extension or compression, it is always positive. It will be always equal to plus half k square. How it is achieved? Not a question that will help you anything. So I will just leave it here. So these are the things that you must remember, because from the next class onwards, we will be getting into the definition of gravitational potential energy. We still are yet to define it. I've given you the answer, but I'll give you the definition. The definition may not be very important right now, because whatever you require is with you, but you must know how it is defined. So I'll give you the definition in the next class. It is also in your notes. I'll show you your notes, and I will just, if you can write this definition on your own, it would save a lot of time. You can do it on your own. So I'll just show you that definition in the notes that you already have. I think you have it in your soft copies, and this is coming to you right away. Potential energy. What is potential energy? Potential energy is defined only for conservative forces. We know this. In the space occupying conservative forces, every point is associated with certain energy. Not every point is associated with energy. Every point is associated with a potential. And if there is something put there, that comes converted into potential energy. Three types of potential energy: elastic potential energy, which is also spring potential energy; electric or electrostatic potential energy; and the third one, gravitational potential energy. No matter what you do, the definition remains same, and this is the absolute definition. This is the correct definition of potential energy, which we'll be discussing in the next class. If you can read it on your own, make the notes on your own, it would save a lot of time. From here till this, if you can write the value of these energies, when write these formulas, it will save a lot of time in the next class. So I'll wind up today's class here on this note. I hope you have understood. We have talked about force, we have talked about field, we have talked about gravitational potential and gravitational potential energies, and I have insisted that the absolute value is not defined. It is always change or difference which is defined. To give the value, to give the point any number, you must have a zero. That zero may be actually somewhere else, but we can take it to somewhere else. For gravitational potential energy, ground will be taken as zero, above will be positive, below will be negative. For spring potential energy, natural length is zero, extension is also positive, compression is also positive. On that positive note, I will finish today's class. See you tomorrow, day after tomorrow, in the next class. If you have any doubts, please come up. Else, the class is a wrap from my end. I hope you enjoyed it. See you. Have a nice day.